Now we will see what is this reflectance, absorptance and transmittance. Yeah, so whenever the heat is going to incident on the body, some part of the heat is going to reflect, some part of the heat is going to absorb, and some part of the heat he is going to transmit over here. So related to that, now we will see, so this concept, which is nothing but your reflectance, absorptance and transmittance. Now we will see what is that reflectance, absorptance and transmittance, that what we had just talked. So this reflectance or absorptance and transmittance, so which is nothing but the total heat which is going to incident on the body, part of it is reflected, part of the heat is absorbed, part of the heat is transmitted. So now the coefficient of reflectance, I will just write it down in short. So this is your R upon Q, then again the coefficient of absorbance, so that is a upon Q, then the coefficient of transmittance, that is a T upon Q. So just divide all this equation by that, your Q R by Q plus your A by Q, then this is your T by Q, which is nothing but obviously Q by Q. So this is your R plus A plus your T is always equals to 1. Yeah, so this is how we can say that. So the amount of heat that has been reflected to the amount of total heat that has been incident, same the amount of heat that has been absorbed to the total heat incident, amount of heat that has been transmitted to the total heat that has been incident. So the coefficient for all of this, R plus A plus T, which is always equals to 1. So next one, now what is this absorptive and emissive power? So this emissive power, it is the total amount of thermal energy emitted per unit area per unit time for all the possible wavelength. Yeah, so this how much it is going to emit. So the emissivity of a body at a given temperature, yeah, is the ratio of total emissive power of the body to the total emissive power of a perfectly black body at that temperature. So we are just going to compare it with the black body temperature. Yeah, so for that particular temperature, so the black body is nothing but obviously it is a body which will absorb everything which will fall on it. Yeah, so we have to compare the emissive power of a given body with respect to that of your black body. Yeah, again we can say that the absorptive power, so again the absorptive power of a surface is defined as the rate of absorption of a radiation per unit area of the surface compared to the surface coated with a lamp black, that is a black body under similar conditions. So we are just going to compare it with the absorptive power of your any body with respect to that of your black body, and you can easily then calculate the value of your absorptive, how much he can absorb as compared to that of your black body, how much he can emit with respect to or in comparison to that of your black body, which we are going to call it as a emissive power. So this is what we can say about the emissive power and absorptive power. The black body is not exist ideally, but practically we can say that. So this is called as a Fairy's black body. The radiations they are going to enter, they just fall on this conical projection, then they get reflected multiple times and the radiation will get absorbed completely. Yeah, you can make the black body, take any body and make, or even if you can give the black color for that, where you can find that the 90 to 95% of the radiations they are going to absorb over there. Or generally we can say that we used to wear the black, you can say that your clothes, yeah, during that your winter for example, which absorb all the heat which is falling on the it, that means it is going to absorb all the kind of radiations, those are going to fall on that your body. So that is what we will say also the black body, that you can just form it. So that is also called as a over here, that is a Fairy's black body for this particular case.